So today we get 3-2 rules and the mean value theorem. And these are more conceptual that things have to happen if these happen. Okay. So the extreme values in theorem 3.1 states a continuous function on a closed interval a to b must have both a min and a max on the interval. Okay. So rules theorem says let f be continuous on a closed interval a, b. So the brackets mean that it is closed. A and b are included in our interval. Must have both a min and max, and differentiable on the open interval a to b if f of a equals f of b. Then there is at least one constant in ab such that f prime of c equals 0. So f prime of c is the derivative, so that means it's a critical number. That means it's a max or a min. So what this is telling you is if f of a equals f of b, and this is a differentiable function, then there is a max or a min in that interval. So the pictures down below show you what has to happen. So in order for f of a to equal f of b, you would have to have some sort of shape like a parabola, correct? Now, what is wrong with the second one? Would this one work?
No, because it's not continuous.
It's not continuous. It has that peak right there, so it is not continuous. So how we use rules theorem is we plug in f of a and we plug in f of b. If they are equal, then you go look for the max or min. That tells you that it's even worth looking for. Good? I thought you were still writing, sorry. Okay, so find the intercepts of this. So how do I find intercepts? Factor. So what's a factor?
What's a factor?
What's the factors?
X.
These.
Minus 2x minus 1.
So x equals 1 and 2. Okay. So since f of 1 equals f of 2, which is 0, what does that mean that happens between 0 and 2?
There's a relative maximum.
There's a relative max or min. Okay, of this equation, is it going to be a maximum or is it going to be a minimum?
It's going to be a minimum.
It's going to be a minimum because this opens up. Okay, and it has to happen since they do equal 0. These are x-intercepts, and so does it have to happen at 3/2?
It does.
Why would I say it has to happen at 3/2?
Because that's between 1 and 2.
Right, and if it's symmetric, which it is, this is a parabola, it has to happen at 3/2. The other thing is if I took negative b over 2a, which would be 3 over 2.
I forgot that was a thing.
Okay, so there's lots of things, lots of ways we could tell this, and I could plug it back in and get my y value, but and most times we just say that x equals 3 over 2. Because if I have an x and I have a function, can I find my y?
Just block her back in.
Yep. Okay, let f of x equal x to the 4th minus 2x squared. Find all the values of c on the interval -2 to 2 such that f prime of c equals 0. So f prime of c equals 0 is what kind of a number?
An extreme.
It's an extreme. It's a critical number, right?
It's a critical number. Not necessarily an extreme.
So what is f prime?
F prime is 4x to the 3rd minus 4x.
Okay, so f prime of x is 4x to the third minus 4x. So I now need to set it equal to 0. Assuming you would all factor out 4x.
Since you're forcing me to.
I know. I'm such a mood. So my zeros of this function are, see if we can do it without factoring it all out.
Without factoring out 0 and plus or minus 1.
Okay, so negative 1, 0, and 1. Now there's a reason I did that. Now, 0, negative 1, 0, 1. That way I can see that number line. I can visualize my x-axis. So my interval is what?
Your interval is negative 2 to 2, so that's all of our intercepts.
Okay, so we're negative 2 to 2, so that includes everything, yes? And if I were to graph this, it would look something like this. Oops. It would look something like that. And we can see that we have an extreme here, here, and there. But again, if we're looking from negative 2 to 2, so if one of those were out of that, we would just not consider it. Questions? Okay. The mean value theorem. So the mean value theorem says if f is continuous on a closed interval a to b and differentiable on the open interval a to b, there exists a number c in a to b such that f prime of c equals f of b minus f of a over b minus a. Isn't that just slope?
Oh, yeah, I suppose.
Okay. So the illustration we have there is we have what they're talking about is when we have the slope of the tangent line, then that would also be the slope between these 2 points, which is a secant line. Now, you do notice that this is not a nice, it's a tilted parabola. This isn't a nice...
How that exists.
How that exists? Well, a lot of times when it's not, when we have other functions of higher degree other than quadratic, I hate to say parabola shapes, but like your U shapes that occur aren't always nice. You know what I mean? Sometimes they're like this.
Yeah.
You know, we were used to seeing this shape when it's an x squared, which is symmetric and everything happens at the same time. But that doesn't happen unless, or it doesn't always happen unless you are with a quadratic. So, good? Okay, find the tangent line. So given f of x equals x minus 4 over x, find the values of c on the open interval 1 to 4 such that f of x equals f of 4 minus f of 1 over 4 minus 1. So first of all, we probably should just figure out what this is, right? I got my eraser on. What this slope is of the secant line, shouldn't we? Okay, so if I plugged in a 4, I get 1, so 5 minus 1 is 4. Minus, when I plug in 1, I get 4. So 5 minus 4 is 1. So it's 1. I think that's all they're wanting, to be honest. No.
We have to find the full line.
Oh, yes, sorry. But no, it says find the tangent line, finding the tangent line. Find the values of C on the open interval 1 to 4 such that I'm going to go back a second. Okay, so the values of C, this would have to be f prime of C, correct? So we need to find f prime and set that equal to 1, because this is 1. I'm like, I had to go back. Okay, so this was 1. So we had 4 minus 1 over 4 minus 1. So it's 1. So the derivative of this, I personally am rewriting it. How about you guys?
I did rewrite it using negative exponents.
Okay.
Actually,
So-
I didn't rewrite it all, I just wrote it.
Oh, yeah. So it's going to be 4 over x squared.
Negative, no, not negative.
So I need to set this now equal to 1.
1, yes.
So 4 equals x squared. So x equals plus or minus 2. And is that in my interval? Not negative 2. So my answer is what? 2. So once you find your slope of your secant line, because this is our secant line, you find the derivative and set it equal to, so you're, because now this, the derivative is the slope of the tangent line. So we're matching the slope of the secant line to the slope of the tangent line. And I honestly think that was the last slide. Yes,
Are you kidding me now to work?
that's it. Now do you see why we were going